So today we are going to learn two different things. We're going to learn the sine law and the cosine law. What we talked about yesterday, we talked about the primary trig ratios, which is SOHCAHTOA and Pythagorean theorem. These we can only use with right angle triangles. Okay? But in real life, we don't only have right angle triangles, we also have oblique triangles. So the triangles that don't have 90 degrees. So today we're going to find the measure of sine and angles in oblique triangles. Okay? So we're going to learn the two different rules or the two different laws that we can use to solve for these triangles. So let's start with the definition of an oblique triangle. So it's any triangle that does not have a 90-degree angle. In case they does not have a 90-degree angle. And when I name my triangle, okay, so I have the triangle, let's say ABC. Remember we said yesterday that angles are written in capital letters and their sides are written in small letters, right? So if I'm looking at side A is corresponding to angle A, which is across from it, and we call it side A. Okay? Angle B, its corresponding side is side B, which is across from it. Angle C, its corresponding side is C, and that's across from it. Okay? Labeling your triangle, again, similar to the right angle triangle, it's important you need to understand how to label it so you can use your formulas properly. All right? So angles are across from their corresponding sides. So when I'm looking at the sine law, or when do I use the sine law? I can use the sine law when I'm given two angles and any side. Okay? If I have two angles and any side, I can use the sine law. So let's look at an example here. That's why I have angle, angle, side, or angle, side, angle. So that's what AAS stands for. Well, let's say if I give you this angle here, and I give you this angle here, and it doesn't matter which side I give you. I can give you side A, right? These are given information. Then you can solve for another side in the triangle. Okay? So here's the scenario when you can use the sine law. We'll talk about it. We'll see examples. It will make more sense when you see examples. Okay? Another scenario would be if I'm giving you, let's say, so this is the case of angle, angle, side. Okay? If I give you angle, if I give you this angle, and I give you the middle, the side here, and I give you this angle, then you can also use the sine law. Okay? So if I have the two angles and the side in between, you can also use the sine law. We'll talk about this once we look at this. So remember that sometimes you have to use the sum of angles to find the third angle. Okay? In this scenario, I can't solve this triangle unless I solve angle C first. Okay? So I have to solve for angle C by using 180 minus the other two angles in order for me to be able to use the sine law here. Okay? We'll look at examples again that helps us solve this. So what sine law says that in order for me to be able to solve for the side, so basically this question will be asking you to solve for side B. Okay? In order for me to be able to solve for the side, sine law says you have B, or let's start with A first. A over sine A is equal to B over sine B is equal to C over sine C. This formula is used to solve for the opposite side, okay? And when you're using this formula, you're only going to use two of the ratios, not all three of them, okay? Can I have your attention on the board for a second? So in this example right here, okay, I know angle A, and I know side A. And I know angle B, and I'm looking for side B, okay? So if you are to use two of these, which one would you use? A and B, right? So because you know A, you're going to have to use A. Because you're looking for the B and you know angle B, you're going to have to use the ratio B. So you see that I know side A, I know angle A. I know angle B, I'm looking for side B. So I have three knowns and one unknown. I can solve. Okay? So in this case, you are picking what part of the formula you're going to use. Okay? Does that make sense? If, let's say, I gave you C and you're looking for B, then you're going to use the C and the B, right? If I change the name of the formula, the triangle, and I call it XYZ, right? This is going to become X over sine X equal to Y over sine Y equals to Z over sine Z. The letters don't make a difference, right? Whatever the triangle is called, PQR, I don't know. Whatever the triangle is called, you can change these as long as the side corresponds to the angle. Side corresponds to the angle. Side corresponds to the angle. Does that make sense? All right. Now, if you know two sides, in this case, the first case you know two angles. In this case you know two sides and one angle, but it must be an opposite angle to one of the sides. Okay? So, and one opposite angle. Okay, so I give you two sides. So let's say I give you this side and I give you this side. Okay, I give you these two sides. Then what angle I must give you to be able to use the sine law? Either angle C or angle B. Because I have to have an opposite angle to one of the sides. Okay, so I either have to give you B, and then I'll ask you to solve for C, okay, or I give you C and I ask you to solve for B, okay. Otherwise, you can't use the sine law in this scenario, okay. If you don't have an opposite angle or opposite side, you won't be able to use the sine law. We'll talk about what law can I use then, okay. So with this scenario, where I have two sides and an opposite angle, I'm looking for an angle, so I'm finding an opposite angle. The formula is the same, but I flip it because then it's easier for me to solve, okay? So I put the angle on the top and the side on the bottom, okay? So that will be sine A over A equal to sine B over B equal to sine C over C. So this is whatever I'm looking for an angle. You want the angle to be on the top. Do you have to memorize these formulas? You don't have to memorize them. There's formula sheets, there's your homework booklet, but at the same time, you're going to find yourself knowing them, right? After you do all your homework, and like it's just a matter of knowing what formula to use, right? And then you should be able to do it, no problem. Again, we're going to only use two of the ratios at a time, right? So in this case, because I know B and I'm looking for C, then I'm going to use B and C. Okay? We'll look at examples. Did you guys copy the formulas down? We're good? All right. So in this question, it's asking you to find the length of D. So you're looking for this. Okay, what is given to me? Two angles and one side. Okay, if I'm looking for, so I have two angles and one side, and I'm looking for a side. Okay, so what formula, if you're looking for a side, what formula would you want to use? So you're going to use the first formula, right? Because you're looking for a side, so your side has to be on the top. Now, are we okay with this so far? So I'm going to call it, instead of A, can I call it D and F? Okay? So we're going to call this E because that's side E across from angle E. We're going to call this D, it's already named, and this is already named F. So what would my formula be with this letter? E over sine E equals D over sine D. So you see how I changed the letter. That doesn't mean we can't use the formula, right? We changed the letters in the formula as well. What's your name? What is it? Andrea? Are you in grade 12 math? Yeah. Okay. When did you register? Okay, because I did not see your name yesterday. Okay, we are doing this lesson. I'll tell you more about it, about the whole course later. All right, so let's plug in the given information. What's my side E equal to? 38 over sine equals, what's side D? Unknown, so I leave it as D. And then sine if you want to solve for the letter D, how can you isolate for that letter D?
You take sine 40 to the other side and multiply.
Right? So all what I have to do here is what we say half cross multiply, right? So I'm just multiplying this part by this part, okay? And then I'm isolating for that letter D. You see how it makes sense? I have 3 known, 1 unknown. Okay? You should not have more than 1 unknown in your equation. Okay? So that will be 38 times sine 40 over sine 95 equals to D. So on the calculator, you're going to do 38 times sine 40 divided by sine 95. You're going to tell me what you got. Sides to how many decimal places? 1 decimal place. What was the answer? 25 exact? 24.5. Because it has to be to the nearest 1 centimeter, to the nearest 1 decimal place, I meant. Okay. Here's something that you're going to have to think about when you're doing your question, especially with trigonometry or with the right triangles, with the triangles, is the biggest angle is going to have the biggest side across from it. Okay? So because my side is smaller than 38, I'm good because the 38 is across from the 95, while the 40 should be across from a smaller side. Okay? So always the smaller angle is going to correspond with the smaller side. The bigger angle is going to correspond with the biggest side. Did I answer the question? Do you understand what we're doing?
Now the question is, how do you know that if you're going to use trig ratio or sine law to respective angles?
When do we use trig ratios? Just with right angle triangles. This one is with oblique triangles. So any triangle that does not have a 90 degree. Okay? So sine law only used with triangles that does not have a right angle. But there's also the cosine law, which we're going to talk about. Okay? Cosine law, there's rules that you can't use. There's no choice. It's either cosine or sine. Okay? But we'll talk about when can I use cosine law too. So, okay? Now, remember that you need to have an angle and its opposite side to use the sine law. Put that in your head somewhere. Okay? You need to, for sine law, you need an angle and opposite side. It's a must. Okay? It's a must. So let's see. To use the sine law, you need an angle and its opposite side. Now, let's look at this question. This question is asking us to solve for angle C. Okay? Again, if I want to use the sine law, I must have an angle and its opposite side. It's an oblique triangle. We all agree with this? All right? So I have an angle and its opposite side. And I have side C, and I'm looking for angle C. Yes? So let's name the sides here first. So this is A, this is C, this is B, which I don't care about because I don't have anything that has to do with B. So, then which ratios I'm going to use? Yeah? So I'm going to have to use A and C. And why did you guys pick this formula and not the top formula? Because I'm looking for an angle. Okay? I'm looking for angle C, so I'm going to have to use this formula right here. So, we said A sine A over A equal to sine C over C. Okay, let's fill out the formula. What's angle A? 59. Over what's side A? 19 equal to, I don't know what angle C is, over 12. You see why we have two different versions? Because to make it easier for us to solve. If you pick the other version, it's not wrong, but then you're going to have to do a lot of flipping. Okay? In this case, all what I have to do is take the 12 and then do the half cross multiply, right? Bring the 12 over, so it'll be 12 times sine 59 over 19. Okay? Can you tell me what you would get for this? Can you give me more decimals here? 6, 5.
Use 1 4. Sorry,
0.54.
yeah, 5 4.
5, 4 what?
541.
1, 4.
1 4.
Okay. The more decimal you use here, the better it is because you're looking for the angle. Okay. So if I'm looking for the angle, what do I have to do? What's the extra step I have to do? The inverse. Which is 30. I'll get back to this page 1 second.